According to the National Electrical Code, steel flex, specifically liquid-tight flexible metal conduit, is generally not permitted to be used as a permanent method of wiring in a concealed location such as a foundation. National Electrical Code Article 350.50 states that flexible metal conduit shall not be used where secured to a building structure other than at points of support. The use of steel flex to adapt the service lateral to the meter panel may not be an acceptable practice under the National Electrical Code. Possible solutions involve several options. Firstly, reroute the service lateral. This involves physically relocating the 3-inch polyvinyl chloride lateral to align with the meter panel knockout. This may require excavation and reconstruction of the foundation. Secondly, use factory-made offset adapters. Explore different types and sizes of offsets to find one that meets the clearance requirements. Thirdly, install a conduit body with an offset nipple. A conduit body with an offset nipple can provide a change in direction while maintaining a rigid connection. This option may require some additional space in the foundation or wall. Fourthly, use a sweep. A sweep is a curved conduit fitting that can provide a gradual change in direction. This can be a more versatile option for tight spaces. Alternative options for concealed wiring include electrical metallic tubing, intermediate metal conduit, and rigid metal conduit. Electrical metallic tubing is a rigid metal conduit that can be bent and shaped to follow the contours of the foundation. Intermediate metal conduit is a heavier-duty version of electrical metallic tubing and can provide additional protection in concealed locations. Rigid metal conduit is the most durable type of metal conduit and is required for certain hazardous locations. It is always recommended to consult with the utilities company and local building code authorities before making any changes to the service lateral. They can provide guidance on acceptable practices and ensure compliance with regulations. When dealing with electrical installations, understanding the National Electrical Code, or NEC, is essential for ensuring safety and compliance. The NEC provides guidelines for various aspects of electrical work, including the types of wiring methods permitted in different locations. In this case, the question revolves around the acceptability of using steel flex, specifically liquid-type flexible metal conduit, as an adaptation for a 400 amp service lateral within a foundation. The NEC generally restricts the use of flexible metal conduits, including steel flex, in concealed locations and where it's used as a permanent wiring method. The primary reason for this restriction is that flexible metal conduits are not designed to withstand the same level of physical stress and environmental exposure as rigid conduit systems. In concealed locations, such as within a foundation, the conduit is more susceptible to damage from moisture, corrosion, and physical impact. National Electrical Code Article 350.50 reinforces this point by stating that flexible metal conduit should only be secured to building structures at its support points. This implies that it is not intended to be a structural component or a permanent wiring method in concealed areas. Given that the utility company has denied the installation, it's crucial to explore alternative solutions that comply with the NEC and local building codes. Several viable options can be considered to address the misalignment issue between the 3-inch polyvinyl chloride service lateral and the meter panel knockout. One option is to reroute the service lateral. This involves physically moving the 3-inch polyvinyl chloride conduit to align directly with the meter panel knockout. While this may require excavation and potentially some reconstruction of the foundation, it ensures a direct and compliant connection. This approach eliminates the need for flexible conduit or adapters, providing a more robust and reliable solution. Another approach is to use factory-made offset adapters. These adapters are specifically designed to create a change in direction while maintaining a rigid and secure connection. It's worth exploring different types and sizes of offsets to find one that accommodates the specific clearance requirements of the installation. Factory-made offsets are typically made of rigid materials, such as steel or aluminum, which provide better protection and durability compared to flexible conduits. A third solution involves installing a conduit body with an offset nipple. A conduit body is a fitting that allows for changes in direction and provides access to the wiring inside the conduit. By using a conduit body with an offset nipple, it's possible to create the necessary offset while maintaining a rigid and code-compliant connection. This option may require some additional space within the foundation or wall to accommodate the conduit body. A fourth option is to use a sweep, which is a curved conduit fitting designed to create gradual changes in direction. Sweeps are particularly useful in tight spaces where a sharp bend would be impractical. By using a sweep, it's possible to redirect the conduit without compromising its structural integrity or violating code requirements. In situations where the above solutions are not feasible, alternative wiring methods for concealed locations can be considered. Electrical metallic tubing, or electrical metallic tubing, is a rigid metal conduit that can be bent and shaped to follow the contours of the foundation. Electrical metallic tubing is a popular choice for concealed wiring because it provides excellent protection for conductors and is relatively easy to install. Intermediate metal conduit, or intermediate metal conduit, is a heavier-duty version of electrical metallic tubing. It offers enhanced protection against physical damage and corrosion, making it suitable for more demanding environments. Intermediate metal conduit is often used in industrial or commercial applications where durability is a primary concern. Rigid metal conduit, or rigid metal conduit, is the most robust type of metal conduit. It provides the highest level of protection against physical damage, corrosion, and fire. Rigid metal conduit is typically required in hazardous locations or where there is a risk of explosion. When selecting a wiring method, it's essential to consider the specific requirements of the installation, including the environmental conditions, the type of building, and the applicable codes and standards. Ultimately, the best approach is to consult with the local utility company and building code authorities before making any changes to the service lateral. These entities can provide guidance on acceptable practices and ensure that the installation complies with all relevant regulations. Failure to comply with these regulations can result in fines, penalties, and potential safety hazards. The key takeaway is that the National Electrical Code prioritizes safety and reliability in electrical installations. Using steel flex as a permanent wiring method in concealed locations is generally discouraged due to its limited physical protection and susceptibility to damage. By exploring alternative solutions and consulting with local authorities, it's possible to achieve a code-compliant and safer installation that meets the specific needs of the project. Remember that electrical work should always be performed by qualified and licensed electricians who are familiar with the National Electrical Code and local building codes. This ensures that the installation is done correctly and safely, minimizing the risk of electrical hazards. The National Electrical Code is updated every 3 years to reflect changes in technology and best practices. Staying current with the latest edition of the National Electrical Code is crucial for anyone involved in electrical work. In addition to the National Electrical Code, local jurisdictions may have their own electrical codes and regulations that must be followed. These local codes may be more stringent than the National Electrical Code in some areas. It's essential to be aware of and comply with all applicable codes and regulations to ensure a safe and legal installation. Proper grounding is essential for electrical safety. Grounding provides a path for fault current to flow back to the source, tripping a circuit breaker or fuse and preventing electrical shock. The National Electrical Code specifies the requirements for grounding electrical systems. Surge protection is another important aspect of electrical safety. Surges can damage electronic equipment and even cause fires. Surge protective devices can protect against surges by diverting excess voltage to ground. The National Electrical Code requires surge protection in certain applications. Arc fault circuit interrupters, or arc fault circuit interrupters, are devices that detect arc faults, which are a common cause of electrical fires. Arc fault circuit interrupters are required in many circuits in homes and other buildings. Ground fault circuit interrupters, or ground fault circuit interrupters, are devices that detect ground faults, which can cause electrical shock. Ground fault circuit interrupters are required in wet locations such as bathrooms and kitchens. Electrical safety is a shared responsibility. Homeowners, contractors, and inspectors all have a role to play in ensuring that electrical systems are safe and compliant. By following the National Electrical Code and other applicable codes and standards, we can reduce the risk of electrical hazards and protect people and property. Continuous learning and professional development are essential for electricians and other electrical professionals. Staying up to date with the latest technologies, codes, and best practices ensures that they can provide safe and reliable electrical services. Electrical inspections are an important part of the building process. Electrical inspectors verify that electrical installations comply with the National Electrical Code and other applicable codes and standards. Regular electrical inspections can help identify potential hazards and prevent electrical problems. Electrical maintenance is also important for electrical safety. Regular maintenance, such as checking connections and replacing worn-out components, can help prevent electrical failures and extend the life of electrical systems. When working on electrical systems, always follow lockout/tagout procedures to prevent accidental energization. Lockout/tagout procedures involve disconnecting the power source and placing a lock and tag on the disconnect to prevent it from being turned back on. Personal protective equipment or personal protective equipment is essential for electrical safety. Personal protective equipment includes items such as safety glasses, gloves, and insulated tools. Always wear appropriate personal protective equipment when working on electrical systems. Never work on electrical systems when you are tired or under the influence of drugs or alcohol. Fatigue and impairment can impair your judgment and increase the risk of accidents. If you are not qualified to work on electrical systems, hire a licensed electrician. Licensed electricians have the training and experience to perform electrical work safely and correctly. Always follow the manufacturer's instructions when installing or using electrical equipment. Improper installation or use of electrical equipment can create safety hazards. If you have any questions about electrical safety, consult with a qualified electrician or electrical inspector. They can provide you with the information and guidance you need to stay safe. Electricity is a powerful force that can be dangerous if not handled properly. By following the principles of electrical safety, we can protect ourselves and others from electrical hazards.